Have you ever looked up at the night sky and wondered, if the universe is so vast, why haven't we found evidence of intelligent life beyond Earth? With billions of galaxies, each containing billions of stars and potentially habitable planets, shouldn't the cosmos be teeming with life? Yet, despite our best efforts, we're met with silence. This unsettling question is at the heart of what scientists call the Great Filter. But what is this mysterious filter, and more importantly, are we destined to encounter it, or have we already survived it? Welcome to today's deep dive into one of the most thought-provoking concepts in science and philosophy, the Great Filter. This theory might hold the key to understanding why we found no signs of advanced alien civilizations, despite the mind-boggling size and age of the universe. Stick around, because by the end of this video, you'll not only grasp the concept but also question humanity's place in the cosmos. The Great Filter is a hypothesis rooted in the field of astrobiology and was first popularized by economist Robin Hanson in 1996. It seeks to address a paradox posed by physicist Enrico Fermi in 1950, famously known as the Fermi Paradox. Why is there a lack of observable extraterrestrial life when the probability of its existence seems so high? The Great Filter suggests that at least one critical step in the evolution of intelligent, spacefaring civilizations is extraordinarily unlikely. It's a cosmic bottleneck, a nearly insurmountable hurdle that prevents life from advancing to the point of interstellar exploration. But here's the catch: no one knows exactly where this filter lies. Is it behind us, meaning humanity has already overcome it? Or is it lurking ahead, waiting to challenge us? Let's unpack the potential stages of this cosmic filter. These stages represent milestones that life must achieve to become an advanced civilization. 1. The emergence of life. Life itself might be the filter. The conditions for life to arise from non-living matter, abiogenesis, could be exceedingly rare. Think about it: Earth's formation occurred roughly 4.5 billion years ago, but it took hundreds of millions of years for the first simple cells to appear. Perhaps most planets never even reach this first step. 2. Complex life forms. Even if life begins, developing complex multicellular organisms is another monumental leap. On Earth, this transition took about 3 billion years. What if this step happens on only a fraction of planets where life begins? 3. Intelligent life. Intelligence is rare. Dinosaurs roamed Earth for over 150 million years without developing advanced tools or technology. It was only a few million years ago that early humans began using fire and crafting tools. Intelligent life might require an extraordinary blend of environmental factors, genetic mutations, and sheer luck. 4. Technological civilization. Once intelligence emerges, it doesn't guarantee a society will advance technologically. Many intelligent species could stagnate or self-destruct before achieving spacefaring capabilities. The cosmic silence. Now, here's where things get eerie. If the Great Filter is behind us, say, at the stage of abiogenesis, then humanity is incredibly lucky to exist at all. But if the filter lies ahead, it could manifest in terrifying ways. Consider this: civilizations might destroy themselves through nuclear war, climate collapse, or uncontrolled artificial intelligence. Or, perhaps the universe is filled with lurking dangers, asteroid impacts, gamma-ray bursts, or even predatory alien species. Why does this matter? Understanding the Great Filter isn't just about aliens, it's about us. If we can identify where the filter lies, we might better prepare for future challenges. It forces us to examine our technological progress, our societal choices, and the fragility of life itself. So, what do you think? Are we the rare lucky survivors in a hostile universe? Or are we unknowingly marching toward our own filter? In the next section, we'll dive deeper into the implications of this theory, explore real-world efforts to search for alien life, and uncover what they tell us about our place in the cosmos. If the Great Filter exists, how can we find evidence of it? Are we truly alone, or are we simply not looking in the right places? To answer these questions, humanity has embarked on an extraordinary journey to explore the cosmos. From scanning distant exoplanets to analyzing the atmospheres of alien worlds, our search for extraterrestrial life has never been more ambitious. But what are we finding, or not finding, that might reveal the truth about the Great Filter? In this section, we'll explore the scientific efforts to uncover life beyond Earth, examine what the absence of evidence might mean, and delve into some fascinating theories that could explain the silence of the universe. The search for extraterrestrial life. 1. Radio signals and SETI. One of humanity's longest-running efforts to find alien civilizations is the search for extraterrestrial intelligence, SETI. For decades, researchers have scanned the skies for radio signals, messages that might indicate the presence of advanced life. Despite examining thousands of stars and galaxies, SETI has yet to find a signal that can't be explained by natural phenomena. This silence, often referred to as the Great Silence, is one of the strongest arguments supporting the existence of the Great Filter. If advanced civilizations were common, shouldn't we have heard something by now? 2. Exoplanet exploration. The Kepler and James Webb Space Telescopes have revolutionized our understanding of planets beyond our solar system. Scientists have discovered thousands of exoplanets, many of which lie in the habitable zone, where conditions might support liquid water, and potentially life. However, as we examine these planets more closely, we found no definitive signs of life. This raises a haunting possibility: perhaps Earth is a rare exception in an otherwise lifeless universe. Possible locations of the Great Filter. Scientists and philosophers have proposed several theories about where the Great Filter might lie. Let's take a closer look. 1. Abiogenesis. One possibility is that life itself is an almost impossible phenomenon. If abiogenesis, the process by which non-living chemicals give rise to living organisms, is extremely rare, this could explain why we've found no signs of life elsewhere. 2. The jump to intelligence. Another theory suggests that while simple life might be common, the evolution of intelligent life is the real bottleneck. Earth's history supports this idea. For billions of years, life remained primitive before the sudden rise of intelligent species like humans. 3. Self-destruction. The scariest possibility is that intelligent civilizations inevitably destroy themselves. Whether through nuclear war, environmental collapse, or advanced technology spiraling out of control, this scenario suggests that every civilization reaches a point of no return. 4. Predatory civilizations. Another chilling idea is that advanced civilizations deliberately avoid contact with others, or worse, they actively eliminate potential competitors. In this case, the silence isn't due to the absence of life but rather to the fear of attracting attention. The rare Earth hypothesis. A closely related concept to the Great Filter is the rare Earth hypothesis. This idea suggests that the conditions that make Earth so hospitable to life are incredibly rare, if not unique. Factors like a stable climate, a large moon to stabilize the planet's tilt, and the presence of a protective magnetic field might make Earth an exceptional case. If true, the rare Earth hypothesis would mean that the Great Filter lies in the improbability of planets like ours forming in the first place. The implications of silence. Let's pause for a moment and consider the eerie implications of this cosmic silence. If the Great Filter lies behind us, then humanity might be a miracle, a rare success story in an otherwise lifeless universe. But if it lies ahead, it raises profound questions about our future. What if our technological progress eventually leads to our downfall? Could artificial intelligence, environmental collapse, or global conflict push humanity toward its own extinction? The answers to these questions aren't just philosophical, they could shape how we approach the challenges of the 21st century and beyond. Breakthroughs on the horizon. Despite the challenges, humanity is making strides in its search for answers. Here are a few promising developments. Biosignature detection. Scientists are developing advanced techniques to analyze the atmospheres of exoplanets for signs of life, such as oxygen, methane, and water vapor. Mars exploration. Missions like NASA's Perseverance rover and Elon Musk's SpaceX plans to colonize Mars might reveal whether life once existed on the red planet, or even if it's still there. AI in astronomy. Artificial intelligence is being used to process vast amounts of astronomical data, identifying potential signals and patterns that human researchers might miss. The silence of the universe may feel overwhelming, but humanity's quest for answers is far from over. In the next section, we'll explore how the Great Filter shapes our understanding of the future, the ethical dilemmas it presents, and the role humanity must play to ensure its survival in the cosmos. The Great Filter forces us to confront an uncomfortable truth: if intelligent civilizations are rare or non-existent, what does that mean for humanity's future? Are we destined to survive and thrive, or are we unknowingly walking into our own extinction? In this final section, we'll explore the future of humanity, the ethical responsibilities we face, and how the Great Filter challenges us to become stewards of life in the universe. We've explored what the Great Filter might be and how it could explain the cosmic silence. Now, it's time to shift our focus inward. Humanity stands at a crossroads. Our choices today could determine whether we overcome the challenges of the future or succumb to the very obstacles that have likely ended other civilizations. Humanity's role in the cosmos. 1. The responsibility of being first. If humanity is the first, or one of the few, intelligent civilizations to emerge, our actions carry immense weight. We're not just shaping the future of Earth but potentially the destiny of life in the universe. This idea places a moral and ethical burden on humanity to preserve and protect life. Technologies like space colonization, renewable energy, and artificial intelligence could help us build a sustainable future. However, they also come with risks. 2. Avoiding self-destruction. Many scientists believe that self-destruction is the most likely form of the Great Filter. To avoid this, humanity must navigate a narrow path. Nuclear weapons. While they've deterred large-scale conflicts, the existence of nuclear weapons remains a constant threat. Disarmament and international cooperation are essential to reducing this risk. Climate change, rising global temperatures, natural disasters, and resource scarcity could lead to societal collapse if not addressed. Investing in clean energy, conservation, and climate adaptation is critical. Artificial intelligence. As AI becomes more powerful, ensuring it aligns with human values and ethics is a pressing challenge. Misaligned AI could pose existential risks. 3. Expanding beyond Earth. One way to mitigate existential risks is to become a multiplanetary species. Colonizing Mars, building self-sustaining space stations, and exploring beyond our solar system could ensure the survival of humanity even if Earth becomes uninhabitable. Ethical dilemmas and the Great Filter. 1. Contacting extraterrestrial life. If we find evidence of alien civilizations, should we attempt to contact them? Some experts warn against this, suggesting that revealing our presence could attract hostile species. Others argue that communication could lead to collaboration and shared knowledge. 2. Preservation versus exploitation. As we explore new planets, we must consider whether to preserve potential alien ecosystems or prioritize human expansion. The ethical implications of exploiting other worlds mirror the environmental debates we face on Earth. 3. The role of artificial life. What if humanity's future lies in creating advanced artificial life that outlives us? Would we consider this a form of success, or would it mean the end of what makes us human? The long-term perspective. To overcome the Great Filter, humanity must adopt a long-term perspective. This means thinking beyond individual lifetimes, political cycles, and even centuries. Building a civilization that can survive for millions of years requires resilience, adaptability, and a commitment to progress. Our ability to work together as a global species, to harness science and technology for good, and to prioritize the survival of life itself will determine whether we pass through the Great Filter, or become just another silent tragedy in the universe. As we conclude this journey, let me leave you with one final thought. What if we are the Great Filter? What if the decisions we make in the next few decades define whether intelligent life continues to thrive or disappears forever? The silence of the cosmos isn't just a mystery, it's a warning and a call to action. Together, we have the power to shape our destiny. So, what will we choose? Will we rise above the challenges, or will we become a footnote in the history of the universe? Let's make this moment count, for ourselves, for future generations, and for the countless possibilities that lie beyond the stars. Thank you for joining us on this thought-provoking journey. Don't forget to share your thoughts in the comments. Do you believe we've already passed the Great Filter, or is it still ahead of us? Until next time, stay curious and keep exploring.